Hello, today's lesson is 11.5, square root functions. Today we're going to identify square root functions and their domains and range, and we're going to graph square root functions. So the function y equals 8 times the square root of x gives the speed in feet per second of an object in free fall after falling x feet. This function is different from others we've studied this year so far. It contains a variable under the square root sign. So a square root function is the function whose rule contains a variable under the square root sign. Here are a few examples. Non-examples. All right, so how do we deal with these type of problems? The first type of problem is that they give you the equation and you simply need to plug this into your calculator. So let's walk through how this would look. If you have the function y equals 8 root x gives the speed in feet per second of an object in free fall after falling x feet. Find the speed of an object in free fall after it has fallen 16 feet. We're simply going to substitute the 16 for the x. Now you don't even need your calculator for this one. This represents 8 times the square root of 16. I know the square root of 16 is 4, and I know that 8 times 4 is 32. So 32 feet per second is the speed. If you want to see how to type that into your calculator, you would press the 8 first, and then to hit the square root symbol, you would press second x squared. Then you could enter 16 and hit enter, and sure enough, it was 32. Okay, let's do another one. We're simply plugging in the 20 for the x. Now this one is not a nice whole number answer, so let's use our calculator. 8 second x squared 20, enter. I believe it asks us to round to the nearest tenth. So I would round 35.777 to 35.8. You try the next two. Use your calculators. All right, hopefully you have 8 times the square root of 25, which is the same as 8 times 5, which is 40 for 2a. For 2b, you needed the calculator here. 8 times the square root of 15 would be 30.98. Let's check that. 8 square root 15, enter. 30.98. Okay, now this looks a little different. Recall that the square root of a negative number is not a real number. The domain, the x values of a square root function, is restricted to numbers that make the value under the radical symbol greater than or equal to 0. So to find the domain, you take the expression underneath the radical symbol and you set it greater than or equal to 0. What we're finding here are numbers we can plug in that will make our y values real numbers. If I plugged in 1, I would get the square root of negative 3. That is not okay. So I need to determine what type of numbers I can plug in. And I'm going to solve this one-step inequality by adding 4. So the x values that I can plug in are any x values greater than or equal to 4. We don't care about this 1 out here. We only care about the expression under the square root symbol. Let's do another one. We're going to take whatever's under the square root symbol and set it greater than or equal to 0. There's a few ways you could do this. You could either divide both sides by 4 or use the distributive property. 4x plus 12 greater than or equal to 0. Subtracting 12, dividing by 4. My domain is the set of all real numbers x greater than or equal to negative 3. So the smallest number I could possibly plug in would be negative 3. All right, you try these two. You're going to just set the expression under the the square root symbol greater than or equal to 0. All right, for the first one, I would add 1 to both sides and then divide by 2. So x is greater than or equal to 1/2. That's my domain. Those are the x values I can plug into this function. For 5b, I'm going to add 5, divide by 3, and the x value is greater than or equal to 5/3 would be the domain for this function. All right, let's look at the parent square root function. The domain in this case is x greater than or equal to 0. If I had to generate some ordered pairs, it makes sense to plug in numbers that I know the square root of, such as 0. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And this is going to generate this little curved shape. This is an endpoint here. We can't go further to the left because the domain is x greater than or equal to 0. Your range, in this case, the y values are also greater than or equal to 0. If you find that endpoint, those x and y coordinates help you write your domain and range inequalities. All right, so obviously if you add or subtract a number after the square root symbol, that's going to translate your graph up or down. If you add or subtract a number within the square root symbol, it moves it left or right the opposite way you think. So the square root of x minus 1 actually translates right 1. The square root of x plus 2 actually translates left 2. These notes are very helpful for the next few activities. All right, so let's try to graph this. First of all, I need to figure out what type of numbers I can plug in. So I'm going to set the expression under the square root symbol greater than or equal to 0. And I find that the smallest possible x value I can plug in is 3. Let's think about that. If you plug in 3, you get the square root of 0, which is 0. Now I need to plug something in to make it the square root of 1. Let's go with 4. The square root of 4 minus 3 would be the square root of 1, which is 1. So I've got another point on my graph. Let's think about the next perfect square. We already did the square root of 0. We already did the square root of 1. The next would be the square root of 4. What minus 3 would give me 4 under the square root? It's a 7. The square root of 7 minus 3 is the square root of 4, which is 2. Now I have enough points to graph my square root function. 3, 0, 4, 1, 7, 2. And the curve only extends to the right. The range in this case, let's look at the y values. The smallest y value here is 0. So the range is y greater than or equal to 0. Remember what I said a few minutes ago. If you find that minimum point, you're going to get the x and y values that you need to write your inequalities for domain and range. To describe this transformation, we would say this translated right 3 units. All right, on this one, we've got just the square root of x, so we can plug in perfect squares and follow order of operations. First, I need to take the square root of 0, which is 0. And then, using order of operations, I would multiply. 3 times 0 is 0, and 0 plus 4 is 4. Now let's substitute 1. The square root of 1 is 1. 3 times 1 is 3. 3 plus 4 is 7. And lastly, we're going to substitute 4. The square root of 4 is 2. 3 times 2 is 6. 6 plus 4 is 10. Let's plot these points. 0, 4, 1, 7, 4, 10. Okay, the domain, of course, is going to be all x values greater than or equal to 0. The range is going to be all y values greater than or equal to 4. There are a few comparisons here between this graph and the parent function. You could say it translates up 4 units. And because of the 3 out in front, this is actually a vertical stretch. The curve seems much more steep or inclining much quicker. We call that a vertical stretch. All right, let's try another one. In this case, we can plug in perfect squares again. So let's go with 0, 1, 4, 9. The square root of 0 is 0, plus 2 is 2. The square root of 1 is 1, plus 2 is 3. The square root of 4 is 2, plus 2 is 4. The square root of 9 is 3, plus 2 is 5. This one was easier to plug in points. So we've got 0, 2, 1, 3, 4, 4, 9, 5. The only comparison I can think of would be translation up 2 units. All right, last graph, try it on your own. Pause the video. All right, we're going to plug in the numbers, and you would get the following points. When you plot those on your graph, you get this curve. And you could say that this was a vertical stretch and a translation up 3. All right, thank you for watching. I hope this video helped with lesson 11.5.